What is curl of a vector field? Curl is a differential operator applied to a vector field to measure the degree of spinning or degree of rotation. Consider a vector field. Suppose F, you can represent F either by I cap F1 plus J cap F2 plus K cap F3, or you may write, if you write in terms of x, y, z coordinate, you may write fx I cap plus fy j cap plus fz k cap like this. So what do you mean by curl of a vector field? Curl of a vector field, suppose f, the vector field is f, is represented by del cross f. That means it will give you rotation. The cross product will give you rotation. If the curl is negative, then the rotation will be clockwise, and if the curl is positive, then the rotation will be anti-clockwise. There will be anti-clockwise rotation. So how you represent the curl of a vector field? Suppose the vector field is f1 I cap plus f2 j cap plus f3 k cap, and this is your del operator. Then cross product of this vector field with this del operator can be represented by this determinant form. This is called the determinant form. So in determinant form, the cross product can be written as I cap j cap k cap del y del x del y del y del y del z f1 f2 f3. If you take the determinant, then this will be equal to I cap, then the product of this and this, that is the del of f3 with respect to y minus del of f2 with respect to z. Then for j cap, it will be equal to del of f3 with respect to x minus del of f1 with respect to z. So in this way, you can find out the cross product to find the curl of a vector function. What is the physical meaning of the curl of a vector function? Suppose you have given a vector v, that is the velocity vector, which is equal to the cross product of the angular velocity with r. R is the position vector. So v equal to omega cross r. If you find out the curl of this angular velocity, then you will find out the curl of the curl of the linear velocity. Then we will find out the value of the curl in terms of omega. That means curl of a vector field is always connected with the rotational properties of the vector field. Now let us discuss how the curl of a curl of velocity vector, angular velocity vector, can be found out in terms of rotational property. You see, suppose you define omega, angular velocity, in terms of its three components, that is omega 1 I cap plus omega 2 j cap plus omega 3 k cap, and the position vector can be written also in three components x y z, that is x I cap plus y j cap plus k z k cap. Then what will be the curl of v? Curl of v will be equal to curl of omega cross r, because v equal to omega cross r. Then this will be equal to the del operator. This is your del operator. When you take the cross product of this del operator with omega cross r will give you this value. Okay, because omega is equal to, we have taken here omega 1 I cap plus omega 2 j cap plus omega 3 k cap cross x I cap plus y j cap plus k z k cap, and this cross product can be written in determinant form like I cap j cap k cap omega 1 omega 2 omega 3 x y z. And if you take the cross product of the del operator with this determinant, then the determinant of this is equal to this, and the del operator, when you take the cross product of this del operator with this value, then you can find out for del operator you write I cap del by del x plus j cap del by del y plus k cap del y del z, and this term, you write this term here, and if you take the cross product of this value del operator with this, then you can write in this determinant form I cap j cap k cap del y del x del y del y del y del z omega 2z minus omega 3y. This is your omega uh, omega 3x. You take omega 3x minus omega 1z. Okay, omega 1z here. If you take plus here, this will be omega 3x minus omega 1z, and this term will be omega 1y minus omega 2y. So the determinant of this value will be equal to 2 omega. Now we see the curl of the vector field V is equal to 2 omega. That is, the curl of a vector field is connected with rotation properties of the vector field, and that justify the name of rotation used for curl.